So today we'll do an intro on organic chemistry. Okay, so to start with, let me ask a question. What is organic chemistry in your own terms? Anyone to help us with the organic chemistry? What is organic chemistry in your own words? Or what are organic compounds? When you hear organic compounds, what do you think they are? I'm sure by now you understand what inorganic compounds are. So now, what are organic compounds? Okay, there's someone giving us an answer. You can speak up.
Organic compounds are compounds.
I don't know if it's only me. We are not getting you clearly. You are a bit low.
Organic compounds are compounds that contains carbon and hydrogen atoms only.
Good. So those are organic compounds. So compounds that have carbons and hydrogen in them, those are going to be termed as organic compounds. Okay. So we also have hydrocarbons. Okay. So hydrocarbons are also compounds that are going to have carbons and hydrogen atoms in them. For example, we can also have other atoms attached to those compounds, the organic compounds, like nitrogen atoms attached to them. Okay, so those are going to be called hydrocarbons. Okay, so now we have different types of hydrocarbons. One of them are called alkenes. So these are a group of hydrocarbons. Okay, so they have a general formula of CnH2n plus 2. Okay, so that's the general formula for alkenes. Okay, so these guys are going to be sp3 hybridized. Okay, so you find carbons which are sp3 hybridized, meaning they will have single bonds in them. You won't find a double bond in alkanes. You are only going to find single bonds in them. Okay, so examples of alkanes, you have here from 1 to 10, we have numbers. We have methane, ethane, propane, butane, pentane up to decane there. Okay, so those are some of the examples of these alkanes, and their formula are given this side. This is not new. I hope people know this. Okay. Then we continue. Okay, yeah. So I was saying these are some of the examples of alkenes that we are going to have. Okay. Okay. Yeah. So now alkenes can be given names. Okay. So we have rules in which we follow when naming these alkanes. Okay. So your test one starts here. So if you don't understand the rules which we use when naming different hydrocarbons, you're going to lose a lot of marks. Okay, so this is where we start from. Okay, so we have the rules that we follow when naming these alkanes. Okay, so one of the rules, the first thing you do is to identify the longest hydrocarbon chain. Okay, so for example, here we've been given this one here. Okay, this is an alkane. Okay, so there are two ways, there are two paths which you can use when naming this alkane. So we can go like this, or we can actually go straight like that. Okay, so if we go straight like that, how many carbons are we going to have? We're going to have 1, 2, 3, 4, 5, 6. So we're going to have 6 carbons. Okay, so if we follow this path like this, how many carbons are we going to have? We're going to have 1, 2, 3, 4. We are having 4 carbons. Okay, so the longest hydrocarbon chain in this case is going to be the straight path. Okay, so meaning when naming this alkene, we are going to follow the longest chain, which is the one having 6 instead of 4. So meaning our alkane, we are going to get the name from 6, which is hexane. Okay, so we're going to have hexane like that. That's the first thing you do when you are given an alkane to name it. Okay, so you identify the longest hydrocarbon chain. Okay, then after identifying the longest hydrocarbon chain, you are going to number your hydrocarbon chain. Okay, and when numbering, you make sure that the closest number should be to the branch where the branch is. You can see here we have a branch here. Okay, so we can either number our hydrocarbon chain from this side to this side, or from this side to the other side. Okay, so if we start from here, we are going to have this as our carbon number 1, this as our carbon number 2, then this is going to be our carbon number 3. And then if we start from the other side, going the other this side, this is going to be our carbon number 1. Then this here is going to be our carbon number 2. Okay, so clearly you can see that the nearest you are getting is from this side. Okay, so from here, from your left going to your right. Okay, that's the nearest you are getting. Here you are getting 3, the other side you are getting 2. Okay, so meaning when numbering, you're going to start from this side. Okay, where you're getting the branch at the nearest number, which is 2, other than 3 there. Okay, so that's what you are having. That's the other rule need to follow. Okay, so you identify a branch where your branch is, then you start numbering and make sure when numbering, the branch should be at the nearest number. Okay, so here you can see the branch is at position 3. If we start from the other side, going the other side, the branch should be at position 4. So rather start where we are getting the closer number. No, my internet is bad today. Okay. Okay. Okay, so continue. Don't know why internet is bad today. Okay. Yeah, so I was saying the second step, you would number your hydrocarbon, make sure that the branch is closer to the is having a low number. Okay. So the third step you want to follow is to position your substituent. Okay, so you need to indicate the position at which your substituent is. So here we follow that we are starting from here going the other side. So our substituent is going to be at position number 3. Okay, then we can name our hydrocarbon here. Okay, so this is an alkane. So the first thing we've done, we've identified the longest chain, which is 6. Then second thing we've done, we've seen that we are numbering from left to right. Then we've seen our branch is at position 3. Okay, then we identify the name of that branch. Okay, so this is a branch we're having. Okay, this is a methyl group. Okay, an alkene, when it's actually not a parent name, it carries YL at the end when it's a substituent. So in this case, since this is a methyl group, so it's going to be methyl like that. Okay, so that's what you're having. So when naming, you say at position number 3, I have a methyl group. Okay, then the longest hydrocarbon chain is a 6-carbon molecule, so it's going to be hexane. Okay, so you add your hexane here. Okay, so those are some of the rules you need to follow when naming alkanes. Okay, so we continue the rules. Rule number 4, we need to list the substituents alphabetically. Okay, so let's say we have this compound here. You can see we're having 2 substituents here. It's the same one. At position number 3, we have 2 substituents. We have a substituent group, which is a methyl group there, and we have this substituent. What's the name of this group here? So we have a methyl group there. And the other one here, what's the name of this substituent? So this is CH2, then we have CH3. Let me try changing the network. Okay. Okay, so I hope people are still seeing what's on my on the board there. Okay, so now I was saying we have two substituents. In this case, we have a substituent there and another substituent there. So this is the methyl group. Then this is CH2, CH3, then with an R like that, an R group. Okay, so it's attached to that R group. This such a group like this one, it's an ethyl group. Okay, so that's an ethyl group. Okay, so now when naming this substrate, we need to follow the alphabetical order. We can see there, we have at position number 3, we have two things. We have two substituents, which is a methyl group and an ethyl group. Okay, so we will follow the alphabetical order. We know that M, and we have M and E. So E will come first, then M will come second there. So when naming, we follow that alphabetical order. Okay, so we know we are at position number 3. At position number 3, we are still having an ethyl group. Okay, also at position number 3, we still have a methyl group at the same position. Okay, then we end with the name of an alkane, which is hexane in that case. Okay, so that's what we do. So it doesn't matter the position where the ethyl group is. Okay, so for example, let's say we are this group. Okay, so let me say we move this group. Okay, we put it here. Okay, at position number at this position. Okay, so let's say we put it at this position. Okay, so let's put it there and then we name it. Okay, so we have CH2, CH3 there. Okay, so if we put it at that position, okay, so when numbering, we'll start from this side. Remember the second loop, which we said when numbering, we have to make sure that the substituent are closer to the nearest number. So in this case, if you start from this side, we are finding the substituent at position number 3. But if you start from this side, we are finding the substituent at position number 2. Okay, so at position number 2 there, we have an ethyl group. Okay, then we move. So this is position number 2, position number 3. At position number 4, we are going to have an ethyl group, methyl group there. Okay, so we have a methyl group. Then we end with the parent name, which is going to be hexane, like that. Okay, so that's what we're going to have. Okay. Okay, so that's what we do, follow the alphabetical order. Okay, then the other rule we need to follow. Okay, so if you're having two or more identical substituents, okay, so you use terms like di. So for di, it will indicate two substituents. Okay, you can use if there are 3, you are going to use a tri. Okay, a tetra if there are 4, okay, and so on and so forth. Okay, so that's what you do. So you use numbers and you use these terms to indicate if there are 3, there are 4, or 2. So 2 you use di, 3 you use a tri, 4 you use a tetra. Okay, so for example, we're having this here, an alkane. Okay, you can see here we have a substituent here, you have a substituent here, and another substituent here. All these substituents are methyl groups. Okay, these are methyl groups. Okay, so now if we were to number it from, are we going to number from this side to this side, or this side to this side? Where are we going to number this from? Where are we going to start from? This side to this side, or this side to the other side? Left to right, or right to left? Anyone to help us? The numbering. Us with the numbering here. Okay, so anyone to help us with the numbering? Okay, so are we going to start from left to right or right to left? The number in there. Where are we going to start from? Low? Anyone?
Any side.
Okay, so we'll start from any side. You can see there, we can start from this side. We are going to have a substituent at position number 2. Even this side, we are going to have a substituent at position number 2. Okay, so we'll start from either side. Okay, so now we have 3 substituents there. Okay, all of them are methyl. So we have a substituent at position number 2, position number 3, and position number 4. If you start from either side there. Okay, so meaning you have 3 substituents which are the same. So all of them are methyl groups. So we are going to list the positions where these substituents are. Okay, so we are saying the first one is at position number 2. The second one is at position number 3. The third one is at position number 4. Then we are giving these names. So if there are 2, you can see here the substituents, the substituents are 3. And we are talking about same substituents. Okay, so don't use like the previous one. Don't use di here because you are seeing 2 substituents. These are 2 different substituents. We are talking about same substituents here. So we have methyl here, methyl, and methyl. These are same substituents. Okay. So we are going to use a trie to indicate that we have 3 same substituents. Okay. So that trie indicates 3 substituents which are the same. And then these are methyl groups. Okay. So we're going to say methyl. Then our longest hydrocarbon chain is actually 1, 2, 3, 4, 5, which is a pentane there. Okay, so we're going to say pentane. Okay, so that becomes 2,3,4 trimethyl pentane. Okay, so that's what we are having. Okay. Okay, so if 2 long chains are variable, follow one with a long lot of branches. Okay, so in a scenario where you're having the longest hydrocarbon chains in one compound, you find that you have 2 longest hydrocarbon chains. Okay, so the one you get to be the parent, to get the parent name, is the one having a lot of branches. Okay, so for example, here we've been given this one here. You can see that if we move from this side, okay, to this side, we are getting 7 carbons. Okay, also when we move from this side going down here, we're also getting 7 carbons. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so either way, even when we move from this side to the other side, we're actually getting 7 carbons as well. Okay, so it's either way, you're getting 7 carbons. So you can either go this side downwards, you can go this side downwards, you can go this side downwards. Okay, so now for you to identify which one is going to be the parent name, you need to find which longest hydrocarbon chain is having many branches. Okay, so let's start with the straight one. For the straight one, so let me just rub. Okay, so for the straight one, from here, there a question. Someone's mic is on. Okay, yeah. So from this side to the other side, you can see that we have this substituent here, another substituent there, another substituent there, and another substituent there. Okay, so we're actually having 4 substituents. Okay, then if we follow from this side going down, okay, so if we follow this path, we are going to have 1 substituent there. Okay, so let me just rub so that okay. So if we follow this path on this side going down, okay, you can clearly see that we are going to have 1 substituent there, okay, another substituent there. So this is going to be a substituent. Okay, so we have 2 substituents in that case. Okay, same even the other side. The other side, if you go this side down, you are going to have 3 substituents. This is a substituent, this is a substituent, and this is going to be a substituent. Okay, so if we move like that, so we are getting 3 substituents. Here we are getting 2 substituents. Then the straight one, we are getting 4 substituents. So when getting the parent name, we are going to follow the one having a lot of substituents substituented. Okay, so the one with 4 substituents, the one we're going to give the parent name. It's the one we're going to follow in this case. Okay, so meaning these others are going to be substituencies. Okay, so now we need to identify the names of the substituents we are having. So we have a methyl here, a methyl there, and another methyl there. Okay, so now we have this one, which is CH2, CH2, CH3. Okay, then the other group. Okay, so now what's the name of this substituent? Okay, so actually, as well,
Propane.
yeah, this is a propane. Okay, this is a propane. Now, since it's a substituent, if it was in a parent chain, it was going to be propane, isn't it? Now, since it's a substituent, we actually give it propyl, like I mentioned when starting this tutorial. Okay. So as you are moving, you notice that you need to develop the art of knowing the names of these substituents. Okay, because in an exam or a test, you are going to be asked where you are going to have a complicated substituent. So you need to develop the art of naming these substituents. Okay, so the name of this substituent here is a propyl group. Okay, so now let's yeah, so I was saying we've identified the substituents and we've also identified the longest hydrocarbon chain. And we are saying we have three substituents which are methyl and one substituent which is a propyl. Okay, so we are going to give it a name at position number 1, 3, at position number 2, 3, 5, we are having methyl groups there. Okay, so since there are three methyl groups, we're going to give it a tri. Okay, so we have a tri, then these are methyl groups, and then at position number 4, we are having a propyl group, and then this, since these are the longest hydrocarbon, it's a 7-carbon chain, so it's going to carry a name hept. Okay, so it's going to be heptane there. Okay, so that's what you are having. Okay, so those are some of the rules we actually follow when naming alkanes. Okay, so the other rule, so when the substituent occur at the same position from either side of the chain, choose the one with the lowest number position. Okay, so I think this has also been mentioned. So for example, here we're having substituents at different position. Okay, so you can see here we have a substituent here, substituent here, a substituent there. Okay, so if we number this one, we have 1, 2. Okay, so we are finding a substituent at position number 2. If we are to number the other one, we have a substituent also at position number 2. So these are the lowest numbers. Okay, so but what we usually do in this case, we will number them, all of them, we see where the substituents are. Okay, so if we start from this side, we're having a substituent at position number 2. So from this side going the other side, we're having a substituent at position number 2. Okay, so let me just say plus. Okay, so we're having a substituent at position number 2, plus we're having a substituent at position number 3, plus we're having a substituent at position. Okay, so this is position number 2, 3, okay, so 1, 2, 3, 4. Okay, so not 3 there. We are having a substituent at position number 2, at position number 4, and also at position number 5. Okay, so we have, if we are moving from this side, going the other side. We are moving from this side, going the other side. We are having a substituent at position number 2. We are having a substituent at position number 3. We also have a substituent at position number 5 there. Okay, so now to choose which way we are going to go. Okay, so we'll add these numbers, we see which one is going to give us the lowest a number. Okay, so here if we add these ones, this is 6. Okay, plus 5, we're getting 11. The other side, this is 5, we're getting 10. Okay, so this tells us that when moving, we'll move from this side going the other side. Okay, so that's the other rule you have to follow. Okay, so in this case, we have substituent at position number 2, 3, and 5. Okay, so we are going to have 2, 3, 5. They are all methyl, so we are going to say a tri. Okay, so they are going to be 2, 3, 5, 2, 3, 5 trimethylhexane. Okay, so that's what you have there. Okay, so we have some practical questions here. Here we are just identifying the longest hydrocarbon chain. Okay, so we are having A. Okay, so let's try A, and we see. Okay, so let me see if people are able to identify the longest hydrocarbon chain. Then the other ones, these are going to be assessments. Okay, and then I'll make video solutions for the remaining ones. Then you're going to find them on the website. Okay, so let's try this one, the first one. So let's identify, then the other ones, they are going to be assessments. You can either send answers in my inbox. They are there in the notes. And the notes are there on the website. I've already uploaded. So you can just inbox me your answers. Then I'll also make video solutions for this one. Okay. And I'll upload on the website as well. So let's answer the first one. Okay. So what is the longest hydrocarbon chain here?
Heptane.
Heptane. Okay. So how are we moving? So heptane should be 7, isn't it? So this is not going to work. Okay. So the straight way, the one which is going to work, isn't it? So we are going to have 1, 2, 3, 4, 5, 6, 7. Good. Okay. So shouldn't waste much of the time there. We can move. The other ones are actually assessments. And then I'll also make video solutions for them. Okay. So now these are some of the AQ groups that I want you to know. Okay. So if possible, you can put them on your wallpaper. These are important. You need to know them. You won't be able to name any compound if you are not able to tell these AQ groups. Okay. So you know a methyl, how it's going to look. So this is the formula for a methyl. It's having an R. An R, it means it's attached to a hydrocarbon chain. Okay. So that's how a methyl group. And the structure, the skeletal structure is going to look like that. Okay. So we have an ethyl, a propyl. Okay. You also have what we call isopropyl. Okay. So isopropyl, it's more like a propyl. Now we blanch it. Okay. So we can clearly see here, we have blanched this propyl. We've blanched it. So we're getting what we call isopropyl. Okay. Then we also have butyl. Okay, butyl group. We can also blanch a butyl group. We are getting isobutyl. We can also have sec-butyl. Okay, so these are more like isomers of each other, the isobutyl and sec-butyl. Okay, then we can have also tet-butyl. These are some of the alkyl groups that you need to know so that when you see such in a compound, in a hydrocarbon chain, you should be able to tell that that's isobutyl, tet-butyl. Okay, so I hope people are clear up to here. Do you have a question or anything? So make sure you follow whatever we are doing. Make sure you follow because these are the building blocks of whatever we'll be doing from now onwards. Okay, so if we leave you here, I don't know if you ever find us. So make sure you ask where you're not clear. No wonder I'm being slow. Okay. So I know some are familiar with these things, but I'm just trying to remind you in case you've forgotten. Then some don't know at all. So we're just trying to make sure that we are on the same page. But this, you are going to find them in your assessments. You cannot avoid such. Your test one, you expect such. Okay, so now we have questions here now. Let's put together whatever we've done. We try to answer these. Okay, so now these are compounds. We've been given compounds here. Okay, so now we are being taught to give the IUPAC name. Okay, for these compounds. Okay, so anyone to tell me which one we should do, then the rest are going to be assessment. I'm just going to do one. The rest I'm going to make recorded videos. I upload them on the website, and if you can answer them as an assessment, you can inbox me, but you'll find the video solutions on the website. So anyone to give me which one we should do here. Okay. So which one should we do?
I.
Okay, so let's go for I. Okay, yeah, good. So you've done well to pick I. So sometimes alkanes, we can actually put them in a cyclic ring. Okay, so when they are a cyclic ring, they are given a name called cyclo. Okay, So you start with cyclo. So you say cyclo. Okay, so you're going to say cyclo. Then if it's a butane, you're going to say cyclobutane. If it's a hexane, you're going to say cyclohexane. Okay, so in this case, most of the time, a cyclic ring is always going to be a parent name. Most of the time, when it's in an alkane. Okay, so in this case, you have a cyclic ring here. So that is going to be a parent name on its own. Then you have substituents which are attached to it. Okay, so that's what you're having. Okay, so in this case, this cyclic name, cyclic ring. Okay, so we can start from any position. Okay, so let us start from that position. So we can number it from the other side, going this side, or from this side, going the other side. Either ways. Okay, but we have to follow the rules we've been talking about. Okay, so now if we move from the this side going the other side, we are going to have a substituent at position number 1. So this is position number 1. We can have a substituent at position number 2. Okay, if we move from this side the other side, we can have a substituent at position number 2 as well. So either ways. Okay, but now let's identify the substituents we're having. Okay, so this cyclic ring, it's a 6 carbon ring. Okay, so you can see there, this 1, 2, 3, 4, 5, 6. So it's going to be a cyclohexane. Okay, so that's a cyclohexane. But let's identify the substituents that we're having. We're having this substituent here and another substituent there. Okay, so now let's identify this one. What's the name of this substituent?
Ethyl.
So that's an ethyl group. So that's an ethyl group. Now let's identify the other one. What's the name of that substituent there? Okay, so we're having more like an ara. This is an ara there. Then it is attached to something like this. So what's the name of that substituent? Okay, using this box here. What's the name of that substituent? You can see there, this is the ara which is attached to this, isn't it? So that's the reason why I'm saying you need to know this box, okay, so that you are able to identify the alkyl groups you are having in a compound. Okay, so in this case, this is a sec butyl, isn't it? Okay, so we have a sec butyl and an ethyl group. Okay, so following the alphabetical order, an ethyl group is going to come first, isn't it? So meaning when numbering, we should do a move like this, okay, instead of going the other side, because you're going to get lowest number possible at here 2 and position number 5 there. Okay, so at position number 2, we're having an ethyl group. Okay, so we're going to say 2 ethyl. Then at position number 5, you're having a sec butyl. Then we finish, it's a cyclic ring, so we have to put cyclo. So we're going to say cyclo. Then it's an hexane. Okay, so we're going to say cyclohexane. Okay, so that's the name of that compound. Okay, are we clear here on I? Well, now we've named I. Okay.
Yes.
Okay. Yeah. So same applies with these other ones. So you identify the longest hydrocarbon chain. Then when you identify the longest hydrocarbon chain, identify the substituents which are there, the position of the substituents, you number them, then you are able to come up with a name. Okay. So this is an assessment. So the remaining ones, apart from the one I've solved, it's an the remaining ones are assessments, the other ones. So you can take a screenshot, then you solve, you inbox me your answers, but I'm going to make video solutions as well and upload them on the website. Okay. So, okay. So the last thing that I would want us to talk about is issues to do with the IHD number. Okay. So IHD number, IHD stands for index of hydrogen deficiency. Okay. So it is also known as the degree of unsaturation. Okay. So this helps us to show how many rings we can have, or pi bonds we can have, or double bonds we can have, or triple bonds. So in short, this IHD number tells us the type of structures we're going to get. Are we having linear structures? Are we having saturated structures? Saturated structures are structures that are not going to have double bonds in them. Are we having unsaturated structures? How many double bonds, if they are unsaturated, how many double bonds are there at all? Okay, so that's a work of IHD. Okay, nothing else. It will just tell us how many double bonds are there, how many rings are we having, how many linear structures are we having, how many pi bonds are there. So you know that for a single bond, you are going to get a sigma bond. Okay, for double bond, that's where you're going to get a pi bond. Okay, so it will tell you how many double bonds are there. So that will be able to tell you how many pi bonds are there. So that's the IHD. It has a formula. This is a formula for IHD number. Okay, so we have 2C plus 2 plus N. This N is for nitrogen, minus H minus X. This X is for halogens. I'm sure people know what halogens are. Group 7 element are halogen. Okay, then divided by 2. Should be able to find your IHD number there. Okay, so just in case you are having oxygen atoms in that molecule, you are going to ignore them. Okay, so remember hydrocarbon molecules, they can be attached to other molecules like other atoms like oxygen, apart from hydrogen and carbon. So you can find nitrogen, oxygens atom attached to that hydrocarbon. Okay, so if at all there are oxygen atoms, we are going to ignore them. Okay, so that's what we are having. So that's what IHD number is. Okay, so this is a table showing what each and every IHD number tells you. Okay, so it's a summary of everything. So when you're having an IHD of 0, okay, so when your IHD is 0, just know that in that structure, there equation. Okay, so if your IHD is 0, tells you that in that structure, you are going to have linear structures. You are going to have alkanes only. You are not going to find double bonds or single bonds. You are only going to have linear structures. Okay. Then if your IHD is 1, okay, so that tells you that you can have a ring. Okay, so you can have a ring in that structure, or you can have a linear structure with a double bond. Okay, so you can have a linear structure with a double bond, which is an alkene, or we can have a ring structure. Okay, so you can have a cyclic ring in that one. Okay, remember that cyclic ring won't have any double bond in it. It will be just a cyclic ring, a normal cyclic ring. That's what you are having when your IHD number is 1. I hope we are okay there. Question came in last semester, test 1 on IHD, both multiple choice and answered in. So you have to know. Okay. Then when your IHD number is 2, okay, so that tells you that in that you can either have 2 rings. Okay. So what I mean by 2 rings, you can have fused rings. Okay. You can have rings which are fused. Okay. So for example, rings which are looking like this. Okay. So that's what you are going to have. Okay. So you can have that, or you can have 1 triple bond. So you can have a linear structure. In that linear structure, you can have a triple bond in it. Okay. Or you can have a linear structure like that. having 2 double bonds in it. I hope people are taking note of these things I'm mentioning. Okay, some of them are not in the notes. Okay, or you can have a linear structure. It's a linear structure. Okay, that linear structure is having a ring structure. Sorry. Okay, so I've already mentioned for a linear structure. So you can have a ring structure, a cyclic ring like this, and then in that cyclic ring, it's having a double bond in it. Okay, so this is not going to be fused unlike this. So you can have a fused ring, or you can have a structure with a triple bond, or you can have a structure with 2 double bonds, or you can have a structure with a cyclic ring with a double bond in it, 1 double bond in it. Okay, so that's what you have there. Okay, so for IHG of 3, so that tells you that you are going to have 3 triple bonds. Okay, so you can have 2 triple bonds, not 3, sorry. So you're going to have 2 triple bond in a linear structure. Okay, so you can have 2 triple bonds in a linear structure, triple bond like that. Okay, or you can have a structure which is having a triple bond in it and a double bond. Okay, so you can have a triple bond and a double bond in it. Okay, or you can have structure, a ring structure which is having 2 double bonds in it. Okay, so you can have 2 double bonds in a structure like that, a linear structure. Okay, or you can have a fused ring like that one, a fused ring which is having a double bond in it. Okay, so you can have a fused ring with a double bond in it. Okay, so these are some of the structures you're going to get. Don't be limited to the ones I've mentioned. There are a lot. So make sure you research more structures you can get when you are asked to come up with the IHD number. Usually the question, how they will ask you a question, is to calculate the IHD number. After calculating the IHD number, they will tell you to draw the structures. Okay, so you will know, okay, if I'm having CH, H, let's say H 12. So here I calculate my IHD number. If I'm getting IHD number 1, I know that I'm going to have 1 ring. So I can come up with a cyclic ring with 6 carbons, okay, like that. So that's one of the structures I'm going to have, okay. I can also draw a linear structure with 6 carbons and a double bond. You notice that if you are to count, you are going to find that in this ring structure, you are going to find that the number of hydrogens are actually 12. And then if you put a double bond here, you will notice that actually in this linear structure, when you put 6 carbons and then 1 double bond there, you'll notice that in that linear structure, you are going to find that the number of hydrogens are 12. Okay, so these are going to be more like isomers of each other. Okay, so they can also ask you why to give isomers. Just know that they're asking you about IHD. Okay, so we'll go back and talk more about isomerism as we are moving. But I wanted us to introduce this organic chemistry so that we have a good foundation. Okay, so for IHD of 4, we are going to find what we call a benzene ring. Okay, so benzene ring is going to be very important for you as a pharmacist. Benzene ring is going to be important because most of the things, okay, most of the compounds you're having as drugs, they are going to be synthesized from this benzene ring. Okay, so you are going to come up with other structures for different drugs from this benzene ring. So this is going to be important. It's going to be the forefront topic when you reach your 3rd year. It comes to organic pharmaceutical chemistry. We are going to discuss more about benzene chemistry. Okay, so for IHD number of 4, you are going to get a benzene ring. A benzene ring is going to look like this. Okay, so it's a cyclic ring with 3 double bonds in it. Okay, so that's a benzene ring. Okay, so that's what we're having when you have an HD number of 4. Okay, so that's what we have. Okay, so there are practical questions there on IHD. Okay, so now let's try to calculate the IHD for the first part. Like just like the other questions, from B going down. So we have 3 assessments. You can give it a try. Then you inbox me the answers. Okay, so let's try this one. So I said, what is the IHD number of 2 hexene? Okay, so let's try to do that. Okay, so 2 hexene, we know that. Okay, so what will be the chemical formula for 2 hexene? So this 2 hexene tells us at position number 2, this 2 tells us that at position number 2, that's where you're having a double bond. Okay, so you more like have a structure, it's an hexene. Okay, a 6 carbon atom. Okay, so this is 1, 2, 3, 4, 5, 6. Then at position number 2, you have a double bond like that. Okay, so now since we're having a double bond there, then what would be the chemical formula for this structure? What would be the chemical formula? So it would be C6H what? Okay, what would be the chemical formula? Anyone to give it a try? Okay, so that should be 12, isn't it? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 there. Okay, so now we can calculate the IHD from there. IHD. So IHD going to be given by 2C plus 2. Okay, then we get plus N. Okay, then we have minus H minus X, then divided by 2. Okay, so we have 2, the number of carbons, they are 6. Okay, plus 2. Okay, the number of nitrogen, we don't have any nitrogen in this formula. Okay, so we're not going to put anything. Then for hydrogen, how many hydrogen atoms are we having? 4. Okay, so we have 4. We don't have any halogen. Okay, then divided by 2. Okay, so what would be the IHD? So here we're getting 12 plus 2, 14 minus 12, we're getting a 2. Okay, 2 divided by 2, we're getting an IHD number of 1. Okay, so now that's why I said that table I'm from showing, you need to know it by heart. Okay, so you need to know that when I have an IHD number of 1, I'm getting these structures. When I have an IHD number of 0, I'm getting such structures. Okay, so you need to know them. Okay, so for an IHD of 1, we always we can have a linear structure. So you can have a linear structure with a double bond, isn't it? You can have a linear structure with a double bond, with a double bond in it. Okay. We can also have a cyclic ring, isn't it? So we can have a cyclic ring, one cyclic ring only, like that. Okay. So these are some of the structures you can have. So if we are to draw the structures, the first one we've actually drawn is this one here. So if, in case they ask you to come up with the structures, the first structure we'll draw is this one. The second structure we'll draw is a cyclic ring, which is going to look like this without any double bond in it, like this. So these are the 2 structures you are going to get from an IHD number of 1. Okay, so are we clear there on IHD? Okay, so you give it a try in the other questions here. Then I'll look at them, but I'll make video solutions and upload them on the website. Okay, so do we have a question before we end the meeting? Okay, is there any question? Okay, so next time we'll continue from here. Okay, so we'll continue. Then if we are having any past paper, okay, so if there's a past paper